ورقتنا الأخرى تتحدث عن استخدام زيوت ايستر للمحولات لرفع مستوى السلامة من الحريق وتقليل التكلفة. يقدمها المهندس حسام الأمين. المهندس حسام الأمين هو مدير تطوير الأعمال في شركة ماتيريالز بالمملكة المتحدة. حصل المهندس حسام على بكالوريوس في الهندسة الكهربائية والإلكترونية من جامعة جون في المملكة المتحدة. لديه خبرة كبيرة في مجالات الطاقة الكهربائية، شارك في العديد من المشاريع والمؤتمرات التخصصية حول العالم. فليتفضل مهندس حسام، معك 20 دقيقة من الآن. مهندس حسام تفضل، معك 20 دقيقة.
شكرا شيرمان. السلام عليكم. شكرا على حضوركم. أنا اسمي حسام الأمين، ولو البروشر كله أنا من بريطانيا. طبعا أنا أصلي عراقي من بغداد. جدا فرحان وسعيد أكون معكم في المملكة. البرزنتيشن راح تكون بالإنجليزي فأعتذر، لكن المناقشة إن شاء الله بعد البرزنتيشن تكون بالعربي. أوكي. حبيت بس أشكر الشركة المنظمة والإخوان بالمهرجان، فشكرا كثير. بارك الله فيكم. So, good morning. My name is Husam Al-Amin. I work for M&I Materials Limited in Manchester, UK. It's a little bit sad to say Manchester because I don't know if you follow football. The football team, Manchester City, lost last night against Moscow. Their position in the Champions League is pretty bad. So let's say I'm happy to talk about the presentation rather than football. So M&I is a very old company. It's in fact over 100 years, and it is initially founded in the London area, and the ownership changed hands. And during the 60s, GEC, the British electrical organization, bought the company and decided to move the company from London to Manchester. There's a big industrial park called Trafford Park. And since then, we are in the same industrial area. And the company, GEC, joined forces with Alstom and became GEC Alstom. And GEC name actually then faded away, became Alstom. And in the 90s, the current owner submitted a bid to buy the company from Alstom, and the company became privately owned, nothing to do with GEC, nothing to do with Alstom. So we are a privately independent run company. The company manufacturer, and we make 4 products, and one of the products we make is dielectric oil, and the dielectric oil here is for transformers, and it is ester based. So the presentation is to do with transformers, and I'm happy to say that talking to a number of safety officers, they think that the oil, dielectric oil or the insulating oil is an important issue. So this is something I hope will be of interest, because commonly used is the mineral oil. Mineral oil is defined from the oil in the ground, which is hydrocarbon, and of course the mineral oil and transformer fires is something we know happens. So the talk is about dielectric oil in transformers, and talk about comparison between mineral oil and alternative to mineral oil like ester. So this is the agenda: mineral oil and transformer fires, physical property of transformers, fluid related to fire behavior, comparative pan ignition test. This is a simple laboratory test. Comparative spray ignition test. This is test conducted by a testing center in in Germany, installation advantages of less flammable esters, and a case study with a Swiss utility, and then conclusion. So we start with why increase transformer fire safety. Mineral oil fires are common occurrence, and I don't think you would be surprised that the most unfortunate transformer fires happen in America. And if you Google transformer fires, I think you would find hit nearly every week of transformer fires. So mineral oil fires in transformers is a common occurrence, and we as engineers try to see what we can do to minimize this risk. Risk to human life, extremely costly in terms of damage and cleanup, knock-on effects, blackouts and so on, and critically, of course, with the utilities heading towards privatization, these have an important effect. Things like the knock-on effect, downtime time, cost, because authorities will have some penalties if there are power failures, and there are some financial penalties too. Transformer replacement will, especially with the power transformers, they take a long time for delivery. Increase insurance premium and damage to reputation, and again with utilities in the trade in the market, their share will be negatively affected if they have bad news in the media. So we talk about fire safety and specifically about flash and fire points. And just to give you the definition of the flash point, defined as temperature at which vapor ignites but will not sustain burning when flame is removed. And fire point is very similar to it, except defined as temperature at which vapor ignites and sustains burning for at least 5 seconds when the source of ignition is removed. So a lot of engineers, when they refer to these, they refer really to the fire point rather than flash point. So you have a table here, and the table we have the synthetic ester, natural ester. There are 2 types of esters, natural and synthetic esters, but both as a group, if you like, they behave differently to mineral oil. And if you can have a look at the mineral oil with the fire point is 170 degrees, whereas both esters are above 300 degrees, and this will be given as a K class. Anything above 300 is a K class, and above anything below 300 is an O class. So when we see transformers with O and AN, ONA for example, this indicates it is filled with mineral oil, and if it is Canan with K and AN, it is indicated that the transformer is filled with either ester or possibly silicon oil. Now, this is an important slide because this is an energy to raise fluid to fire point. So how much energy is needed to ignite the dielectric oil? And you can see here in the mineral oil, for example, you have, for example, on the energy needed to reach fire point, it's 147 MJ, whereas the esters, synthetic 430 and natural ester 476, and these are roughly about 3 times more. So you need 3 times more energy to ignite ester in comparison to mineral oil. We're going through a couple of tests. The first test is a simple laboratory test, and what we have, I'm going to attempt and use the, So we have a tray filled up with oil, dielectric oil, and with the help of the epoxy acetylene torch, we're going to try to ignite the dielectric oil, and we're going to monitor the temperature with the help of thermocouple. So the two top pictures that are related to mineral oil, and after 3 minutes, with the help of the torch, you can see that the mineral oil is burning or flashing, and after 4 minutes, the mineral oil actually catching fire, as you can see clearly there. Now, in comparison, this is with Eisther. We do the same test, but this time with Eisther. And the Eisther, you can see that after 3 minutes, 100 degrees centigrade, there is nothing there. There is no ignition. And after 1 hour and 10 minutes, that's a long time, there is absolutely nothing apart from maybe the hot flash. So you can see that both experiments show clearly that the mineral oil ignited relatively much easier, whereas the Eisther resisted the ignition. This is the second test. This is a test, we have a lot of tests, but because of the limited time with the allocated to each presentation, I'm selected only these two tests. This is a spray ignition test, and this is similar to what happened to our previous speaker yesterday in Jordan, where the generation, one of the turbines had a diesel, and the diesel was sprayed into a hot surface and ignited and then caught fire. So we try to simulate this condition in this test. Comparison test between mineral oil and synthetic ester, simulate tank rupture through a broken weld with fluid spray under pressure, aim to realistically represent a transformer housing wall, direct the ignited spray into a heated steel backplate and collect the spray below the black plate to create a pool of fluid. You will see this in a video. So this is the equipment setup. What we have is the pressure from the top. This is the tank, and the tank will be heated under pressure.
Mr. Hassam, 10 minutes left.
Thank you. And then we have the nozzle with the help of the propane flame. We have the back plate, and then as well as we have the pan to collect the oil. Okay, so this is done by DMT in Dortmund in Germany, and based on a version of DIN EN ISO. This is the testing methodology, as we explained. This is the first video, and this is the mineral oil spray video. So there is some sound there, please ignore the sound. But what you see here is that the mineral oil is being ignited, and you can see that the mineral oil caught fire here. And the operator here, I'm sorry with the light, maybe it's not very clear, but it's, if you can dim the light a little bit, please, if you could.
منظمين ممكن تطفوا الإنارة شوي صراحة.
You will see that the mineral oil actually causing havoc here, and that is exactly what happened to our colleague in Jordan. And I guess if they have the video there, it would be very similar. And the fire officer conducting the test didn't like what's happening, and he's going to stop the test because this is spreading. And he used the fire equipment to put the fire off. So clearly, mineral oil is caught fire. The same experiment, exactly the same, but this time not mineral oil, but it is synthetic ester, and we're going to see what will happen with this test. So it's exactly the same conditions, same scenario, and this is the spray and trying to ignite the ester, and it's ignited a little bit, and then it's off. It's not sustaining the ignition. And again, he's going to try again after a few minutes. There's nothing happening also there. And he continued to try to ignite ester without any success. So I think it should stop in a minute. But with the mineral oil, if you remember what happened, that the oil was caught fire, and the fire continued to the back plate, and then the fire hit the pool fire. With this one, because there is no ignition, this condition didn't happen at all. So again, both tests, both videos, I think we will have the conclusion slide after this.
5 minutes.
Okay. Thank you very much. Okay. So, spray ignition test conclusion. All reasonable measures were taken to ensure consistent test condition across the fluid, both fluids. A pool fire did occur with mineral oil cause an evacuation. A pool fire did not occur with synthetic ester. And the top North independent report states a pool fire could not be created by the ignition of the spray of the direct ignition of the pool surface in MADA 7131, which is the synthetic ester. These synthetic ester, or ester in general, more expensive than mineral oil. These are the slides to show you there are benefits if you use ester instead of mineral oil. These are IAC standards, FM Global. FM Global is a worldwide insurance company, and they state in their guideline that significantly reduce clearances. NFPA, again, previous speaker yesterday highlighted the NFPA 70 guideline. It's an American standard. Again, they call for no need for transformer volt for indoor installation less than 380 kV with when you use ester. Just one last thing here. The last standard is related to rolling stock. There are a lot of train projects in the kingdom, a lot of metros, and in Europe they only use K-class. So it's either ester or silicon, but they do not use mineral oil. Okay, so advantages of reduced separation, less space required for installation, cost of land, more equipment in smaller areas, and ideal in urban areas. Ideal in areas, for example, in center of cities, especially in the holy places, Makkah al-Mukarramah, Medina al-Munawwara, and so on, where the space are very, very limited. Here we have just a sketch where you show two mineral oil filled transformers, and as per the IEC and FM guideline, you must separate it with a firewall as well as a firewall against the building, and you have to have separation of 7 meters, 15 meters, and a big area there. The same transformers you could use to fill them up with ester, and you will have a much smaller area, and you can have it very close to the building. You can see clearly a big saving in the area, and this could be an advantage in areas like the holy places. Again, these are the other benefit of using ester. You clearly can see here with the firewall of 3 hours as well as 2 hours, and then there is no firewall at all. Here is a case study. SWISI is an Institute of Safety and Security, Risk Assessment and Loss Prevention consultant conducted a study to assess different fire safety situation, fire risk comparison of synthetic.
2 minutes, Mr. Hassam.
I'm going to round it up. So this is a case study, and it's KWO is a utility in Switzerland. It's a power station, and they had four 50 MVA transformers, and these are the transformers. They could not use mineral oil full stop because the fire officers objected to it, as well as the insurance people objected to it. So they filled it up with Midol 7131, and you can see clearly, maybe not so clearly, but you've got 4 units, 1, 2, 3, 4, and they are fitted, installed very close to each other, no firewalls at all, no barriers, and in approximately a very, very small area. I think that would be that. Thank you.